Great. I actually remember to start the recording. Well, good to see so many of you out and about. Got 15 or so of you have logged in at the moment, which is good. Sometimes I worry. I can see on the learning management system there's engagement statistics and metrics, and it's easy to just get lost in numbers and start exploring things. But I look at the number of times things have been looked at and the percentage of the class that's done things. I think, oh, it's sort of a bit scary. But I guess it's 5 weeks to go, which is a long time. And what I can't see is how many of you are making good progress on those assignments, which are quite possibly well underway. And even if they aren't, in my experience, it's remarkable how quickly an assignment can get done when there's a looming deadline. So, gosh, 20 people, that's very good. Very much enjoying your drawings. So yeah, we'll just give ourselves a couple more minutes for people to log in. Do have a plan, of course, for today. We'll just try and focus more on the morphological and histological appearances of the skin and endocrine tissues, but we'll try and reflect that back to the lectures as well. I love Van Giesen has appeared on the screen. Yes, isn't it beautiful? I quite like special stains. When we'll talk about Van Giesen as a special stain today as well. That's sort of stain of the week. Very exciting. Yay. Trichromes. That's right, lots of excited chat going on. Let's go and have a look perhaps at the plan for today then, seeing as we've someone's written certified cool guy up there. Oh, if only my family believed that too. Always have to screenshot that and take it home as evidence. But it's not going to be the case, is it? So let's have a look at the plan for today. Keep drawing your flowers, I love them. I think I might draw in, I'll keep drawing in blue. Yep, so hi, lovely to catch up with a bit of drawing. It's supposed to be very therapeutic. As always, I did think when I embarked upon this sort of transition to online, I would have to sort of rewrite all the practical manuals, but you'll see if you log on and have a look at them, that I've pretty much left the lab manuals as they are, just to try and make sure that I try and stick as close as possible to them, not do anything extra, not add to the learning and so forth. But as I did last time, we'll have a look at the other resources. I know this Collaborate session is the only scheduled thing we've got, really. But there's plenty else going on that you can look at without spending hours and hours and hours, that I think will really help reinforce topic by topic. So today we're going to have a look through the skin and endocrine tissues. What I'll do, we'll start off by a few low power scans from our 5-slide set, like we do each week, really. Try and think, right, what can I even recognize these skin and endocrine tissues at low magnification? And sometimes even with a poor quality image. What is it that's helping me to identify these tissues? So I'll have a look at those. I've also got a couple of low magnification video scans of the weekly skin and endocrine slides as well. So we can see things a bit more clearly and sort of focus our discussion a bit more. I've got some images that I photographed over the weekend. So embarrassing. I came in here to photograph the slides. I was expecting to have them digitized by now, but the company who's digitizing them, they're trying to upload them from their home, and you can't. You can't upload massive digital files of virtual slides from home. It takes you days, as they are discovering. So I came in to photograph them at the weekend and asked security to let me into the microscope room. And I was getting really cross after half an hour and they hadn't turned up. I thought, such a waste of time. Anyway, it turned out I'd told them the wrong building number. So I'd sent the poor security guy on a 10,000 step escapade. Anyway, he did get me into the building in the end. So we do have some nice close-up images of our slides that we can look at and have a chat about. Oh, that's a leftover thing from last week. I've already done that. So who knows, maybe we'll find some hemosiderin this week too. But really we're going to focus on our Van Giesen stain, which is about connective tissues. A couple couple of other things. We'll have a chance at the end to have an assignment catch-up. And I need to remind you, so I'm going to do now, that a pulse survey has opened up today. Yes, it's April the 28th. I can't remember how long it's open for, but it does say on the learning management system. Right up at the top there, I'm just checking on my other screen to see if I can see it. Why can't I see the pulse survey? That's very strange. That is very strange. I must have uploaded it onto the wrong year or something. Oh no, there it is, right at the top. It's right at the top of the LMS. And it says, please complete this very brief pulse survey. It's only 4 or 5 questions. There are 20 prizes, get this, of a $50 voucher from either Amazon or Kohl's online. And that's opening today, and it's open until the 4th of May. So if you can go into the link at the top of the LMS, it's so close to the top, I kind of missed it myself, but it is there, right at the top. And there's a sort of 4 or 5 questions we'll just smack through, a bit of feedback about how things are going. So we've still got a few weeks remaining in the unit to chop and change anything that's critical. Thank you. Good. Someone found an interesting Van Giesen stain slide. Excellent. Maybe you'd be able to share it with us later on. So that is the plan. The pulse survey is opening up, and wow, somebody's done it already. Unbelievable. Good. So everyone are happy about that? Any other questions or stuff to catch up, or anything you want to put on the agenda, if you like? No? I might turn my video off, because who wants to see me, but just to make sure the, thanks for the smiley faces, Paris, that's great, just to keep the quality of audio good and spare you the agony of staring at me. Right, oof, great. You now have to imagine me rather than see me, mercifully. Well, let's move on and have a look, see what's going on. So resources, yes. So same sort of slide as we looked at last time, but there are, of course, a couple of lectures for us to look at. You can play those back at normal or fast speed, or maybe just look through the PowerPoints, whatever you want to do, but I'm hoping they mutually reinforce this session. Don't worry if you haven't seen them already. We'll have to learn on the hoof, even if you come in cold today. The manual is lurking online, of course. That has a little bit of useful information. Just flick through that, a few pictures, information, and so forth. But a couple of key things I would draw your attention to on the manual are a couple of those quizzes there. So there's a quiz there on safety aspects of Van Giesen, always useful to look at. But also this quiz, the second one on Van Giesen staining, sort of guides you through bit by bit the principle of the Van Giesen stain. So you can slash through those 6 or 7 questions pretty quickly, but I'm hoping that quiz will be a sort of interactive way of trying to help you understand how the Van Giesen stain works, which is, of course, an example of a trichrome. Now, feel free to ask questions at any time, or scribble on the board, or tell me to go back at any time. I'm trying not to give a lecture. Hard sometimes, though. So the other resources, of course, which we'll actually look at today are the slide images, which we'll go through those. So they're actually down here in the PowerPoint. So if you go onto the Lab Practical tab in the LMS, you'll see the little videos we're going to use today, and I'll go through them live with you. And you'll see the little PowerPoints if you want to look at the slides yourself as well. For skin and endocrine, we do have in the Murdoch annotated slides, we have skin, and then as endocrine organs, not many actually. We've got pancreas, which of course got the likes of Langerhans there, and there is a thyroid there, but the thyroid is no longer annotated. I had to take down the annotations because someone wanted to use it for an exam, another unit. But there is also the virtual histology guide from the other provider. I can't remember which university it is. That has quite a nice mixture of the endocrine tissues. That's not a completely smooth, zoomable interface. It's got about 4 or 5 magnifications, but it's really quite good, terrific. So again, you can punch through those things really quickly. You think, oh, 10 minutes, you can smack through quite a bit. As far as the ebooks goes, again, if you want to do something quick, it's not a matter of sitting down for hours, is it? You think, oh, 10 minutes, might just do a bit of histology catch up. You can find yourself some nice 1 or 2 page summaries on histology at a glance. This one's obviously on the skin. And then for a more detailed discussion, that man and mouse comparative histology book's really quite beautiful. This picture here, I think, is showing the location of the adrenals right next to the kidney, hence the name. So quite a few resources to dip in and out of. And hopefully, I do find personally that looking at the same topic in several different resources is a good way of learning it, rather than, say, going through the same lecture notes over and over again. Looking at the same thing several times in different formats can be useful. Okay, so let's go and have a look at the 5-slide set, see if we can spot some rat tissue. So I'm going to share my screen. Let's go back to my control panel and click my way through to sharing the application screen, which I think must be this button. I'll share you that. A couple of seconds for it to power up, and here it is. Okay, so we're going to scroll down to the lab practical resources, and I've put the I've put the rat tissues in their own little folder. So here we go, there, 5-slide set of rat tissues, 1, 2, 3, 4, 5, all in that folder at the bottom. It's these videos are pretty short. I'll maximize and get a decent sized screen. Here we go. Here we go. So let's just stop here and go back a bit. We are looking for any skin or endocrine tissues. So if you want to shout out in the chat box or anything, any opinions of what's going on, give me a shout. Because the first mystery we come across, let's just play a little, is something like this. This could be all sorts of things. Anyone want to kick us off by bravely putting a suggestion in the chat panel as to what this organ could be? Well done, Felicity. So thymus, good guess. It's sort of lobulated and so forth, and it could well be the thymus. Any other? There's probably another couple of things that look a lot like this at this power. Yes, pancreas looks a lot like this at this power. So the thymus is lobulated and it looks quite dark because of all the lymphocytes. And the pancreas is lobulated as an exocrine gland, isn't it? And it's quite dark because it's very busy and has lots of RNA and ribosomes, which are the cytoplasm, a very purple feeling. But in fact, this is an exocrine gland. It's not the thymus. If it was the pancreas, what would we see if we zoomed in a little bit more that would help us be sure it was the pancreas? What other feature would we hope to see? Say, oh yeah, that's right. Well done, everyone. Well done, Lean Taylor and everyone. So the islets for Langhans, that's right. And in fact, we zoom in, we don't see them, but we do see ducts and acini. So this is an exocrine gland. Not a mixture of exocrine and endocrine like the pancreas, but a purely exocrine gland. In fact, it's a salivary gland. So zoom on round, but I agree, it could have been the pancreas. So good guesses, and it does look a lot like the thymus. Oh, just to say, on low power, I reckon even at this magnification, we would have seen a pale medulla if it were the thymus. So right, let's carry on scrolling through this. Scrolling around a bit, start and stop. Looking for some endocrine tissues. I think it's getting exciting. Okay, so this is interesting. What's going on here? We might remember this from last week, actually. What have we got here? Because we do. Yeah, that's right. Yeah, well, on Taylor and Neem, we've got a trachea. That's right. Got trachea lurking here, and quite right to say there we have the thyroid. Yes, and how lucky that this section has cut through the parathyroids as well. In fact, I don't think it was luck. I think it's me spending ages with a scalpel. But we've got the thyroids and the parathyroids in this section. And there's not much. How are we recognizing them? I mean, it's like there's not much detail. You can't histologically recognize them here. What is it that tells you this is thyroid and parathyroid? Yep, the size is appropriate and relevant. I agree. And that's right. It's actually an anatomy exercise, isn't it, really, or microanatomy. Their locations, those bilaterally symmetrical organs next to the trachea, is just what we're after. Brilliant, brilliant, brilliant. Right, we've nearly finished this first slide, I think. Let's scroll around a bit. Any more endocrine tissues? Ooh. Interestingly, side by side here, we have got two glands. There's a salivary gland over here in the lower right-hand corner, and I can't tell what this one is. Yeah, I think you're probably right earlier that this is probably the pancreas. But at this magnification, I mean, there are a couple of pale areas which could be islets of Langerhans. So it's probably our pancreas. So it'd be hard to tell this magnification. Zoom on around a bit. Around we go. I remember what these dark organs were that we saw last week. What are these two things? Yeah, they're the lymph nodes. That's right. In fact, you can beautifully see their cortex and medulla there. That's really quite nice, even at this low magnification. So then there's a bit of gut or something. Oh, it looks like that's the end of that slide. So let's get out of this one. Escape out of that slide. Look at the next one. So we found thyroids and parathyroids so far. Just whipped past the kidney so quickly you probably didn't notice it. And recognize that, don't we? Yeah, spleen, well done. Yeah. Yes, we've just gone past the heart down here. Now there's two big organs here. What make the, well, one big organ and one smaller organ. So we've got a hypothesis for ovary at the top. Now, of course, we haven't done reproductive tissues yet. So if it was an ovary, so it's good to log, thank you for bravely suggesting things. If it was an ovary, what else might we see? I know we haven't done it yet, but what other things might an ovary have in it? Yeah, that's right. Well done, Taya. So follicles. So follicles are sort of large fluid and blood vessels, of course. Yeah, well done. So follicles are large fluid-filled things, and some are really quite big. Whereas all these little circular entities in this tissue are very even-sized. And in fact, are they really circles? Because some of them, cut this way, look more like tubes. So if that was an organ full of tubes, that is a little bit different from the ovary. In fact, it is a reproductive organ. Anyone know what it is? We've had a few clues. I know we haven't done it yet. Yeah, well done. It's a testis. So if it's a testis, that's essentially a collection of seminiferous tubules all called up. And if we were to zoom in, we would see them. Interestingly enough, while we're here, and I appreciate this is one topic too early, if we were to look in between these seminiferous tubules, there is an endocrine component there. Does anyone know what endocrine component nestles between the seminiferous tubules? You don't really think of it as an endocrine gland, but there are, in fact, some interstitial cells, some Leydig cells that secrete hormones. We'll come on to that later when we do the reproductive system. However, it is this little joker here in the lower left-hand corner. Yeah, well done. That's the adrenal. That's quite a call because there's not much we can see. But what clues have we got that it's the adrenal? And you are correct. Well done. What clues? Not really. Yeah, that's right. It's the overall structure of a sort of a nodular gland, isn't it? Divided up into cortex and medulla. Quite right. Yeah, well done, everyone. That's really good. Really good, and maybe the shape too. So let's noodle on through this. Any more on this slide? Can't remember. A couple of seconds to scroll around. looks like it's, oh, that's the end of that slide. So we found a few. Any endocrine ones on this one? Let's have a look. Anyone remember what this tissue was? It caused a bit of confusion last time. Yeah, it's the eye, so we're beginning to recognize it now. Well done, got that retina. And the thing that makes it confusing is the lens is relatively so huge in rodents, isn't it? A bit of spinal cord. Oh, and we seem to have a theme of dark glands. So remember we've got a sort of multi-choice one here, isn't it? Of thymus, pancreas, and salivary gland. What are we going to go for? I think you can tell it's magnification, actually. Yeah, well done, Taylor. So thymus, it's lobulated. Yeah, well done, Lean. It's lobulated, and I think the thing that's really helping us is it's got a really clear cortex and medulla. This pale medulla here and the surrounding cortex. Those are the clues that give it away. Now, this particular set of slides, I think that is where the fun ends. Oh, we've got the next one, of course. This will be an easy one. It won't take very long. Let's pop it up to the big screen. What are we looking at here? It's actually quite damaged. Yeah, well done. It's skin, and it's quite damaged. Don't want to. Of course, we're interested in damage because that's all part of our portfolios. What do you think the issue is? Even at this low magnification, we sort of said, oh, the slide's a bit damaged. What is wrong with this slide, do you think, at low magnification? What sort of problem that, even without zooming in, yeah, there's some sort of, maybe it's cutting damage, hard to say where it's come from, but the key thing is there's tissue missing, isn't there? When you look around here, there's sort of big cavities. If that's the dermis, well, it's empty. So either the cutting didn't work very well or tissue has been lost during staining. So yeah, there's certainly something not quite right about that skin. Yeah, who knows? Who knows when that could have happened? I think if it was a dewaxing problem, you would have seen very pale staining tissues. Whereas I think as we scroll through this, it really does look like tissues have been lost from the slide, which is slightly different from a dewaxing appearance. But anyway, we'll move away from that. My computer's struggling with that one. Okay, so that's a 5-slide set. Let's get back to where we were on our little slideshow. Here we go. So here are the 5 slides we just looked at. Who wants to, why don't we get a quick arrow of drawing on the thyroids and parathyroids? Where are they? Can you see those? I want to draw on the screen where the thyroids and parathyroids are. Yep, well done. Someone's got them right up there. That's good. And what else could we see? Oh, where is the adrenal on this collection? Can we see it now? Oh, well done. Yeah, gosh, well done on finding that. I was struggling to find it myself, actually. But yeah, that was the adrenal lurking there. And the thymus is nice and easily recognizable. Wants to point out where the thymus is. Yeah, beautiful. That's the dark tissues are really easy to recognize, aren't they? Terrific. Okay, well, let's move on. I should say with the other class set that we've got, let's just go on to the next slide. In the other class set, we did have on slide E, which you can see has got these sort of cross sections of a vertebral column. Some of them also had pituitary on, but on that particular set of 5 that I photographed, I couldn't find it on. The pituitary is very small, and why would it appear on some slides and not others? They're all cut from the same block, aren't they? So how come, if they're cut from the same block, how come of the 60 or so slides we've cut, some have got pituitary in, but some have not? Where did it go? Why is that? There are a couple of reasons why, even when the slide's been cut from the same block, some slides might not have that tissue. Anyone want to venture some suggestions as to why? Yeah, that's right. So we think, well done, please. You sort of think they're identical sections, but we're not. We're advancing each time the microtome cuts. It's cutting through our block. And so something like a rodent pituitary, which is small, you can cut through it. Whereas the other tissues on the block, like these vertebrae that you see on the right-hand side here, these are really quite thick, and you can cut through those hundreds and hundreds of sections before losing them. So yeah, so some of them just haven't got the pituitary on because it's been cut through. Great. So let's move on and have a little look as to what we see here. So very easy to recognize these tissues. This is one of the class slides. Now, how about, where is the epidermis on this? So these are two sections side by side. I'm hoping you recognize some skin. Yep, so be careful when you highlight. We've been quite specific, haven't we? Yes, so it is almost drawing a line to find the epidermis. That's right. So it is literally that thin layer of epithelium on top. Well done. So how far down does the dermis extend to then on these slides? Where will we draw that? So we've got a couple of suggestions. A couple of different opinions here. So on the left-hand side in blue, someone's saying that dermis only extends as far, and someone else has backed that up. On the right-hand side, we've got differing opinions, haven't we? We've got differing opinions. So some people are saying the dermis only extends down here. We've had a couple of votes down here. So in fact, the slide on the left has been correctly identified. Let me get my pencil in. Let's get a green pencil for me at the moment. So on the slide on the left, the dermis is this thickness here. So well done, people who've got that. Yes, and quite right. Thank you for writing out on the right-hand side. Feel free to lob in and get involved. The dermis on the right-hand side, I'm highlighting in green here. So it's pink, or pinkly stained, I should say. And as one of you has so correctly said, this bit that I'm drawing around now is in fact a hypodermis. So the skin here is split into epidermis, which is always surprisingly thin, dermis, which is pretty thick. I guess that's leather. You know, when you see a piece of leather, that's mostly dermis. And what's a predominant component of the dermis, do you reckon? If you had to say the dermis is made mostly of, and there's a couple of ways of phrasing it. Anyone want to suggest in chat or text on screen what the major part of the dermis is going to be? So the epidermis would be stratified squamous epithelium. What about the and keratinocytes? What about the dermis itself? And that I am excluding the epidermis and the hypodermis. The dermis, let's just get my little hand going again. So the dermis around here has got not much epithelium in it at all. That's right. So it's mostly collagen, fibroblasts, and so forth. So by weight, collagen's probably the biggest component. Okay, good. Yes, it has you can just about see the adnexia here. So let's move on to a slightly greater magnification. Oh yeah, just going back one bit actually. The strange thing that we haven't talked about is this really basophilic tissue down the bottom here. So think where it is. We've got dermis at the top, and then down the hypodermis. So muscle is a good guess because anatomically you would hit muscle the deeper you go. So good guess based on anatomy. Well done. But when we zoom in, yeah, that's right. We find it's not muscle, is it? Well done, Felicity. It's actually exocrine tissue. And can you see some ducts? Anyone will draw some ducts? That's right. So the yellow is quite a low contrast to me, but you pick out those ducts straight away, and then most of the rest of the tissue is sort of acinar tissue, you know, secretory cells arranged in grape-like ducts. So of course, sweat glands is a reasonable guess because you think, oh yeah, skin, glands, it's only the sweat gland, isn't it? So as we'll see later on, sweat glands are higher up and they're tubular. This is a compact lobular gland. If I told you that this was taken from the cheek of a pig, just behind its jaw, we might be able to have a better guess at what. So yeah, almost as good guesses. Yeah, well done, Paris. So salivary gland, when you think about the anatomy, would be up there. So salivary gland is anatomically in the right place, so it's a good guess. And also it's an exocrine gland with ducts, which is a good guess. As we'll see later, thyroid has a slightly different structure, and the thymus has a different structure too. So yeah, unexpected really to see salivary gland lurking on there. Anyway, so gosh, tell you what, if I how about if someone writes with text on the right-hand side, features they can see, or several people, and then someone else can draw the, you can use a text tool, you can draw links between text on the right-hand side and feature on the left. Yeah, okay, so let's label this diagram somehow. Well done, good. You can see a hair follicle. I'm getting my text tool out. Yep, someone else has labeled something. Oh, it's all building adipose tissue, fat. Yeah, well done. We're determined users of the, yeah, that's sweet sweat gland is lurking there. Even its low magnification, nice and identifiable. Ooh, someone with sharp eyes has got some sort of, there's another secretory gland, isn't there, halfway up that, or there seems to be. Ooh, oh, well done. Someone has found, it's quite exciting watching the label unwrap, has found the rector pilar muscle there, which is faint. Well done on spotting that. But this secretory gland, let me get my little hand going. What sort of secretory gland? It's a little bit hard for me to see it, but it's in the right place. What type of secretory gland are we hoping to see halfway up there? Yeah, sebaceous gland, well done. Yeah, sebaceous gland, so that we'll label that. And then we could, if we were going to stay here much longer, we could label dermis and hypodermis and epidermis. And oh, yeah, that's good. Someone's labeled stratum corneum on the top. You can actually, at this magnification, it's clear enough to see the stratum corneum. Dermis is going to have to be down here a bit. Now, and that pink line on the top is the epidermis. Yeah, where the red line is just, someone's just put a red line through it. That's the epidermis. Yeah, that's right. So let's modify that. Epidermis at the top because of the epi. Dermis in the middle. Then below, hypo, is the hypodermis. Good. I think we've sort of smashed through everything we can on that one. Nice. Moved off. Sorry. Just mid-drawing. Oh, it's just refresh with an eraser. There we go. So, what features can we see here? We have to be quite careful with our labeling if we're going to label this. Ooh, something beginning with D. Yes. What is that thing? Dark nuclei. Well done. So we're beginning to get quite expert at picking up staining artifacts. Can anyone remember why we get these dark nuclei? What sort of thing? Maybe it might be easy to pop it in the chat panel. But yeah, tissue drying out. Yeah, well done, both of you who've replied there. Yeah, tissue drying out during the staining. Good. Well, meanwhile, back on screen, we've got a basal there being outlined there. That's stratum basale. Yeah, that's good. I'll tell you what then, I'll pick out a feature with my little green pen. What's this little joker over on the left? And I wonder whether there's another one there. What could they be? There's a few possibilities, as always. Always a few possibilities as to what they could be. But they do look a little bit different from the surrounding keratocytes, don't they? So we've got a suggestion there of melanocytes. That's right, that is a possibility. It could well be melanocytes. Any other ideas of what they could be? So in that, if we were thinking about what cells there are in the epidermis, we've talked about keratinocytes, and I know they have different layers. Yeah, so we've got keratinocytes, and the other cell Felicity's mentioned there is melanocytes, but there are some other cells that you see in the skin. When you think of all the different functions of the skin, think, oh yeah, it's protection, pigmentation. Yes, so sort of. They're related to monocytes in a way, because monocytes become macrophages, which are an antigen-presenting cell. So we have the sensory cells of Merkel. So some of those look like these clear cells. So in the epidermis, you do sometimes see clear cells, such as this one here. And they can be, as we've said now, Merkel cells, melanocytes, or what's the name of that specialized antigen-presenting cell that we see? Yeah, that's right, the Langerhans cell. Good, yeah, dendritic cell, Langerhans cell. So there are those. Now, just to scroll back a bit, mast cells are another good suggestion, but mast cells are going to be patrolling around under here in the dermis. And anyone remember what a mast cell is going to do? What does a mast cell do? We've raised it here, so we should follow through. So quite right, mast cells are seen in the dermis there, but what do they do? That's right, they produce histamine. And what sort of thing might make them degranulate their histamine? Which, yeah, so they have it's a specific thing, isn't it? They have immunoglobulin E as a receptor on their surface. And when they come across an antigen that cross-links specifically that particular IgE or antibody, that mast cell will degranulate. So that's an allergic reaction. So your skin gets bright red in response to something you touch. There are physical stimuli, like cold, heat, and trauma, I think, that can stimulate your mast cells. Yeah, scratching. That's right. So that's why you get the itch, scratch, itch cycle. A little antigen might trigger off your mast cell, then you get itchy from that inflammation, so you scratch it, and that just is the cause of inflammation, that local trauma. So it keeps going. Don't scratch. Oh, not too though, isn't it? So the other feature we can see is that on the left-hand side, when you look at the basal layer, it undulates gently. But what's nice on the right-hand side, when you look at the basal layer, it's really shows quite a marked undulation. I've actually got to name those features. Anyone knows what those undulating bits poking out the bottom are there? And why they're there? Because they're not so prominent on the skin on the left. Why has the skin on the right got these bits poking down? What even are they? What even are those bits? It's actually not a plane of section artifact. These things are Reti ridges. I've popped it there in the chat box. So Reti ridges or Reti pegs, and they help with anchorage. So thick skin, like on the sole of your foot or the palm of your hands, will have thick anchorage points and deep Reti ridges, whereas skin on your forearm, less so. Yeah, it is. That's right, Taylor. It's just increasing the surface area for anchorage and to stop it sliding off. Righto, so these are just from the lectures, just to remind us that in those lecture notes you'll find out about the layers of the skin and the different layers of the epidermis, and then the clear cells we talked about, melanocytes, dendritic cells, Langerhans cells, and Merkel cells, and what do you do? So you'll find that all in the lecture notes. Okay, let's move on. So now we've got a little bit better magnification here, haven't we? We can. What's the next one after this? Oh yeah, we'll go back to this one a bit. What's a general term for the structures indicated here? There's probably a collective term for the I don't know, 3 structures indicated on this slide. It's been mentioned already, I think, way back in the comment earlier. The hair follicle, yeah, the hair follicle there is part of this set of structures. But we can see the hair follicle there. Someone wants to draw around it while we're waiting. What else can we see apart from a hair follicle? Yeah, we can see the rectopilar muscle. Someone can outline that as well if you've got a pen going. And the sebaceous gland, that's right. Yeah, good. So that's rectopili. Sebaceous gland, a little bit hard to see. Not quite accurately outlined in red there. A little bit, yeah, that's it, that's the one. And where's the sweat gland in this one then? We should probably squiggle around that one, because it is here. That's right, sweat gland looking at. So collectively, we would call these the adnexi. Okay, so the adnexi or the adnexal structures. We've mentioned it before. So slightly greater magnification now. You can see these. Well, you can't quite see that they're foamy, can you? But a little bit of sebaceous gland. Yeah, that's right, halfway up this follicle. Very nice. Right, let's move on to the next slide. So here around the outside, you can see little reserve cells. And these are dividing away to make these larger cells here. And then you can just about see they're foamy, depending on how you adjust the microscope. I think I've just got this one photograph. But what is that mode of secretion where the entire cell, so this whole cell, is shed into the follicle where it ruptures and spreads its contents all over? There's a term for that mode of secretion. Yes. The mode of secretion. Endocrine is when you secrete into the bloodstream, isn't it? There's a word ending in crine, C-R-I-N-E, for the mode of secretion when the entire cell is shed. Paracrine is when you're communicating with the cell next to you. Exocrine is through a duct, so we're beginning to resolve some of these. Yeah. Autocrine is when you sort of secrete a chemical messenger to yourself, so we're getting there bit by bit. We're getting through the crines. There's one crine that we haven't mentioned yet. So autocrine is secreting a sort of self-stimulating factor like a growth factor. Exocrine is through a duct. Endocrine is into the bloodstream. Paracrine is to a nearby cell like an interleukin. It is holocrine. So holocrine is that mode of secretion where the entire cell drops off, which is what the sebaceous gland is doing. Now, if I just, these slides are identical, A and B. A and B. Why do you think the resolution is not so good in B compared with A? What adjustments might have changed? It's not the focus, by the way. The focus has stayed the same. What adjustments are there made to alter that? Yeah, that's right, the condenser. So the condenser, and in particular, the iris aperture diaphragm that forms part of the condenser, if that's open too wide, it goes a bit hazy, like this. If you narrow it down a bit, you can increase the resolution. So yeah, well done. So you can really see the difference there. Great, and so I'm just referring back now to the lecture slides. The lecture slides talk a little bit more. Actually, one of you did comment on the isthmus, halfway up the hair follicle. Comments about how the hair follicle is divided up into 3 parts, and we've got a few labeled slides that go through that, and also the growth cycle. So you can, if you haven't already seen that lecture, that'll help resolve those bits. So lastly, I think from the skin, this is a nice human skin biopsy. You've got quite deep, reedy ridges. Yeah, but what's this that someone has drawn attention to? It's sort of on the edge of the section. So let's generate a few possibilities. So it's a pigment, that's right. So melanocytes are a possibility because we are on the skin. So melanocytes, well, excuse me, I slept like a complete opposite of a log. You know when you sleep like a log, it's good. What's the opposite of that? Anyway, whatever that is, I slept like that last night. So excuse the yawning. So yeah, melanin is a good suggestion. Slept like a wood chip. Yes, I feel like I've been through the mulching thing. Hemosiderin is another good suggestion for a golden brown pigment. Well done, folks. These are good suggestions. Neither of those is correct, funnily enough. Yeah, disappointing. So in fact, this is not an endogenous pigment, it's an exogenous pigment, and someone has put a surgical marking ink to show us where the edges of this biopsy are. So that's surgeon's marking ink. So either the surgeon's put it on shortly after she's taken the biopsy, or maybe the pathologist put it on in the cutting up room. So, you know, which is a genuine edge of tissue and which is not a genuine edge of tissue. Okay, so a bit of marking ink, that's all that is. Yeah, so someone's put a question mark down there. Look, they look like little ducts, don't they? Ah, actually, at that thickness, it's probably going to be an arteriole. Yeah, and when you think about it, these pink things that have been highlighted here, just got my little hand drawing circles around them, which is strangely therapeutic. I just rotate my hand gradually. It's sort of active meditation. Those pink walls probably mean it's smooth muscle rather than epithelium. So I suspect those are little arterioles. Thanks for pointing those out. Righto, so now we're moving on to one of the endocrine glands we saw earlier on. You recognise this one? Yeah, that's right. So back at the adrenal gland, what features can be seen at this magnification? Not much, admittedly, but you know, it's slightly better than the low power. Yeah, we can see at least 2 layers probably. Does someone want to start highlighting layers? Because maybe there's more than 2, I don't know. So if you want to mark up the slide a bit. Yep, so we've got quite a thin outer one, yeah, in blue there, and then there's sort of a middle one, which that red double-headed arrow has picked up. And then there's, yeah, almost a smaller one in the middle. So how many layers do we generally say the adrenal gland has? Yeah, almost. So that's right. So 3 or 4. So interestingly, and 2 is correct as well. So if you're going to say 2 layers, we'd say adrenal cortex and adrenal medulla. But the cortex itself is divided up into a further 3 layers. So maybe that's 3 cortical layers plus the medulla makes 4. Who knows? Let's have a bit of a look. The other thing you can see over on the right-hand side is a bit of adipose tissue and a bit down here. I think I zoomed in on that because it was slightly interesting. Oh, yes, but only slightly. So here we are looking at that tissue. So someone's picked out an arteriole, do you reckon there? Well done, whoever's picked that out. So using an arrow, something a bit more precise, let's pick out a few adipocytes, shall we? I'm not really trying to trick anyone. Well done, probably one there. Bit hard to see, isn't it? Yep, highlighted a whole area of them. Most people are choosing, that's right. So most of the things itemized have been, but there's 2 sorts of fat in this photograph. What are the 2 sorts of fat that are visible here? Yeah, white and brown. So where's the brown adipose tissue then? Let's find some of that. That's right. So you can see it's different. And the features that make it look different are, well, the nuclei look central almost. That's very different, isn't it? Because in the white adipocytes, notice how the nuclei are all peripheral. Maybe a little bit smaller, a bit hard to tell, but they do have a greater, yeah, that's right, well done, Philippa. They've got lots of mitochondria in them, which is why they're staining up that color. And who remembers what brown fat does? Who remembers what brown fat does? So this is just the fat surrounding the adrenal. That's right, it generates heat in babies. That's right. And outside our species, who else has a bit of brown fat? What's it used for? It's generating heat as well. But yeah, I don't know about penguins and pigs actually, but hibernating animals have a bit of brown fat. I think they do, I think, to generate a bit of heat. So actually, having asked the question, I'm unable to answer it myself with those specific suggestions of bear, pigs, penguins. Mice certainly do, but certainly hibernating animals have a bit of brown fat. And do you remember they uncouple phosphorylation to generate heat? Yeah, sort of by the way a little bit, really. So here we are. Where is the outer zone of the cortex in this picture? Who can draw? That's right. So in red that's right. In red now, we've got the outer zone, And what is the name of the outermost zone of the adrenal cortex? Anyone know what that is? Bit of a mouthful. There is a fibrous capsule right on the outside, quite right. I forgot to mention that. But in fact, there's a zone of secretory cells, the outermost zone of the cortex. Anyone know what that is? I'll give you the clues. There you go. Oh, well, we've already got it. Beat me to it. Well done. The zona glomerulosa. Well done, Guthrie. So the zona glomerulosa. Partly because when you look at it at greater magnification, sometimes in some species, those cells do form little loops or structures that sort of resemble glomerulin. Anyone know what it produces? The zona glomerulosa. So this is the endocrine lecture. So it is stimulated by renin via the angiotensin system. So the pathway to produce mineral, that's what a lovely unfolding narrative. So the zona glomerulosa, the stimulus is renin released from the juxtaglomerular cells and that whole Golgi apparatus and macula densa in the kidney in response to falling blood pressure. And that renin acts on angiotensinogen in the circulation to produce angiotensin 1, as Guthrie has said. And then angiotensin 1 is acted upon by angiotensin 2 by angiotensin converting enzyme. Where is ACE and why is this topical? Where is angiotensin converting enzyme and why is this particularly topical at the moment? So we're talking about what stimulates aldosterone release from the zona glomerulosa. We've said that's a renin angiotensin aldosterone system, and the angiotensin is converted from 1 to 2 by angiotensin converting enzyme. Which location do we find ACE? It's not the kidney. Sounds like we're going to have to. I'll tell you what. So angiotensin converting enzyme is in the lungs, and ACE is the receptor also for what? It's quite topical. Well, angiotensin converting enzyme, I understand, is a receptor for coronavirus. Oh my God! Yes, that's right. So very exciting. So who would have thought we've managed to wangle the conversation around the coronavirus on a histology talk? But there we go. So renin in the kidney is produced in, that's right, dramatic piano sting. Wish I could do that. Maybe someone has a piano at home and they could turn the audio on and play something. Anyway, so renin in response to falling blood pressure is released from the kidney, acts on angiotensinogen in the blood, give angiotensin 1. That's converted by ACE, which is a receptor for coronavirus, in the lung to angiotensin 2, which acts on the zona glomerulosa to reduce aldosterone, which has been said earlier to cause sodium retention and potassium loss in the kidney. And of course, if you retain sodium, you retain the water with it, osmotically, and bingo, your blood pressure rises. And if you remember, a blood pressure fall is what set this whole thing off. Fabulous. Now we've already said the name of this middle zone. That's earlier in the comment, the zona fasciculata. That's right, so we've got the zona fasciculata, and that is going to release cortisol. Well done. So Guthrie summarized nicely that ACTH, where's that come from? Where's that ACTH come from? Adrenocorticotropic hormone. Where is that released from? Anyone know? That's right, from the pituitary gland. So if you look at that name and break it down, adrenocorticotropic hormone, that is obviously acting on the adrenal cortex, here specifically this zone to make cortisol, and away you go. But being a bit meta, what causes ACTH to be released? Like one step back. Yeah, so up in the hypothalamus or hypothalamus, a releasing hormone comes down from the hypothalamus to cause ACTH release. Anyone know the name? It's quite a sensible name of the releaser hormone that comes down from the hypothalamus. So what we're talking about really is the hypothalamo-pituitary adrenal axis. It's not ADH. No, it's not ACTH. It's actually corticotropin releasing factor, or CRF. Great. And then in the zona reticularis, anyone know what goes on in the zona reticularis, which is this last zone of the cortex? Actually, I do have a mnemonic. It's not really a mnemonic. Way of remembering the zones. Okay, I can switch to blue because it's a bit more visible. G, F, R. GFR, a bit like glomerular filtration rate, isn't it? So GFR, that's how I remember the zones of the adrenal cortex, or I used to before it became embedded. And so quite right, so reticularis can get rid of androgens as well, sorry, secrete androgens, well done. And then, where is the actual adrenal medulla? Because now we're talking about adrenaline release, Taylor's raised that. Where is that medulla on our picture? Quite right, yeah, I think you've picked it out quite nicely there. And in fact, even with this magnification, I can see a staining artifact, which is most noticeable probably in those pale cells of the adrenal medulla. Yeah, dark nuclei again, don't they, Sharpwell? Superb. I'm not sure we've got another slide here. Oh, so here we are right at the outside. We talked about the capsule, which is very thin, right on the outs here. That's me drawing around here. The zona glomerulosa here in this species does not really look like glomeruli, but that's what it is. But the fasciculata, so fascicles mean bundles, and I don't know, maybe you do get the impression that these cells are arranged in little bundles, you know, with like little sinusoidal blood vessels between them. So zone G and zone F nicely shown up there, I think. And picked this one out partly because these fabulous dark nuclei are haunting us like a swarm of bees or termites or something. Well done. Yeah. So this, if you go back to the endocrine lecture, that will talk us through how, you know, releasing hormones, corticotropin releasing hormone comes down there, goes to the anterior pituitary in this particular instance to release ACTH, which acts on the adrenal cortex to release cortisol, which has all those features that we talked about. And then this is just a low power slide of the adrenal. In the high power slide of adrenal, actually it does look more, but when you look in the glomerulosa on this adrenal, it does look more glomerulus-like. So here the zona glomerulosa sort of higher powered, and the fasciculata higher powered. And this is just that little summary about fall in blood pressure triggers renin release from the macula densa and juxtaglomerular apparatus of the kidney, which acts on plasma angiotensinogen to give AG1, an angiotensin converter enzyme in the lung. It's a very bad picture of a coronavirus, just to remind us. Creates angiotensin 2, which acts on there to release aldosterone, now, which causes sodium retention and fixes the blood pressure. So what does angiotensin do, apart from cause the stimulation of aldosterone, to help with this fall in blood pressure? So it doesn't just cause aldosterone release. We call it the renin angiotensin aldosterone system, as if aldosterone is the end product. Angiotensin does something else, and when you look at its name, that is a clue. So the angio prefix, that means blood vessel, and tension is due to pressure. So angiotensin causes vasoconstriction. Well done, Nicholas. Causes vasoconstriction, which will increase the total peripheral resistance and therefore drive up the blood pressure. So angiotensin, that's what the name means. That's where it all came from. Terrific. So that's something to pick up from the endocrine lectures. Let's move on. Not far to go, I don't think. So, now We saw a bit of this earlier at low magnification, but at high magnification now, which particular gland do you think we are looking at? There's nothing else that looks quite like this, I think. It's almost got a unique histological appearance. Yeah, it looks like thyroid by the mini picture, that's right. And so if we zoom in a bit on this thyroid, quite right, we should see its classic appearance. So thyroid, quite interesting. It's got this, they're spheres really, lots of closely packed spheres or follicles, which have, what's this stuff in the middle? There's probably a couple of correct answers. Yeah, colloid. So colloid or thyroglobulin, that's a storage form of thyroid hormone. So thyroid hormone is one of those, you know, hormones you can sort of categorize into sort of steroids and non-steroidal hormones. Steroids just pass straight through cell membranes and act on, you know, intracellular receptors, sometimes intranuclear, sometimes intracytoplasmic. Thyroid hormone also passes through membranes, so often you can't really store these hormones very well, but in this instance, the thyroid gland actually stores them in this sort of thyroglobulin form where it can't diffuse through membranes. So it's just one way of storing a hormone which normally wouldn't be storable. So just zoom in a little bit, and the thyroid epithelium is here, but in addition to the endocrine cells of the thyroid, there is in fact another type of endocrine cell lurking in this gland. Now, we've talked about the parathyroid, I'm not talking about that one. There is another category of endocrine cell, and you could probably scribble on the picture where you think it is, if you know what it is. So up there in the thyroid, we've got the parathyroids too, but there is another endocrine cell that lurks in the thyroid, easily forgotten. And in fact, the parathyroids, what do they do? Because it's a clue as to where I'm going. What is the action of parathyroid hormone? What does it respond to? What's it correct? Anyone know? So parathyroid hormone, that's right, parathyroid hormone acts on the bone. Well done, we've got parathyroid hormone at the moment. So parathyroid hormone acts on the bone. And what is the result of parathyroid hormone on the bone? Not talking about growth. Parathyroid hormone acting on the bone is actually to do with homeostasis of a particular mineral. That's right, it's calcium. So in response to a fall in blood calcium, that's right, well done. So fall in blood calcium, the parathyroid hormone is released, and that releases calcium from the bone to correct it. So the other cell, the other hormone that Nicholas has mentioned is calcitonin. Where would calcitonin come from? It's a different gland. It's not the parathyroid hormone from the parathyroid. It's not thyroid hormone. It actually comes from their own specialized cells called C cells. They're called C cells because they secrete calcitonin. And so C cells are actually intercalated within the thyroid itself. So if we had an antibody for calcitonin, it would probably show up scattered little intercalated cells lurking around here, the C cells. So they are within the thyroid. So they are anatomically part of the thyroid, aren't they, the C cells? Let's just go back to clarify this. Let's go back a couple of places. So this tiny picture on the left-hand side, we've got the parathyroid. Now they are anatomically distinct. You could probably very carefully cut them out, haven't you? And then next to them, we've got the thyroid. I must say that sometimes the parathyroids are actually embedded in the thyroid, so not that easy to cut out at all. But I'm now talking about a population of cells, these little blue dots that actually sit within the thyroid, between the follicles. So in fact, in this whole area, we've got three categories of endocrine tissue. We've got the thyroid shown here. We've got the C cells shown here. We've got the parathyroids bolted on the outside. So nice little separate cluster of cells. And then we've got these little pink stripes. What are these? This sort of pink line here in the thyroid. What might that be? Because they were quite prominent on the previous picture. Let's go to low magnification. So we've got a line there, got a line there, all over the place. And we'll zoom in. So photograph A, photograph B. Aha. A and B. So I'm actually adjusting the focus here, and you can see that they are wrinkles. That's right. You don't have to adjust the focus on a picture of my face to see wrinkles, but you do have to adjust the focus on this histological slide to see the wrinkles. So that college is just wrinkled up and made these sort of abnormal folds. Folds or wrinkles, yeah, quite right. Well done. Excellent. Excellent. So let's zoom on to the next slide. So this slide reminds us a little bit about the endocrine lecture. And again, from the anterior pituitary, we have thyroid stimulating hormone, an example of a tropic hormone, acting on the thyroid, which, as you said in the comment, releases T3 and T4, and as you said in the comment, is important for growth, metabolic rate, maturation, and so forth. And we talked earlier about another tropic hormone, ACTH, acting on the adrenal cortex. So up here on the right-hand side, here's thyrotropin, or thyroid stimulating hormone, coming down, acting on those that stored form of the hormone to become the active form, T3 and T4, and then that has these functions here. And then we also mentioned, we didn't look at the histological structure so much of the parathyroid gland, which is here, sitting next to a thyroid gland down here. But in response to falling blood calcium, that's detected by the parathyroid cells. They release parathyroid hormone, which tell osteoclasts to pump those protons out, dissolve that bone matrix, release the calcium, but also increase the gut absorption from renal and gut sites, just to bring calcium back in normal. And the opposite side of that are these little cells here, which show up quite nice in this photograph, located in between the thyroid follicles in response to a rise in calcium. They secrete calcitonin, which decreases the activity of osteoclasts and pimps up the osteoblasts a little bit to get calcitonin back in the bone. Now, in humans, most of the calcium regulation is actually done by parathyroid hormone, although there is a potential sort of yin-yang between these two hormones. Calcium is not so important. Suffice to say, in certain species, cattle spring to mind, you do sometimes get tumors of the C cells. That means you're going to get excess calcitonin. And in fact, that means these animals end up with really thick bones, which makes sense, doesn't it? And in fact, there are a number of diseases, tumors included, where you get excess parathyroid hormone release. And of course, excess parathyroid hormone will pull out all the minerals from your bone, or a lot of it, and you end up with very soft bones. In fact, no, actually, sorry, just to go back to Philippa's contact, those tumours in cattle aren't actually related to milk production, because it's sometimes in bulls, which obviously don't do it. I don't know why cattle are a species in which it happens more often than others. Anyway, with excess parathyroid hormone, you leach the calcium out of your bones, and a lot of museums have pictures of ribs which have actually been tied in a knot, because they've only got the sort of collagenous components left. You also see it in chronic kidney disease, because of the disturbances in phosphate. That tends to accidentally cause this secondary hyperparathyroidism. And you can get x-rays of dogs or something with chronic renal disease, and almost all you can see on the x-rays are teeth, because the skull bones are so weak. In fact, if you squeeze their canines, you can actually make the canines pivot towards one another, which is probably very hazardous. Good way of getting bitten, I suspect. Anyway, we'll just finish off briefly with this discussion of the Van Giesen stain. So you'll recognize the first stage, we're de-waxing in xylene, and why would we have 2 changes for 3 minutes each rather than just 6 minutes? Why is it better? Yeah, that's right. So fresh xylene is avoiding that problem of, if we've got xylene 1 and xylene 2, and you put your waxy slide into xylene 1, some of the wax will come off that slide into solution. So now we've got a sort of wax contaminated xylene 1. Then after a few minutes, you put it into xylene 2, and you've got sort of fresh xylene there with very little wax contamination, little happy face. And so you get much better removal of the wax, and you might even have a xylene 3. So you know that this xylene 3 is going to stay wax-free for a longer period. So during the course of lots of staining, this xylene 1 will have quite a bit of wax lurking around in it. If that's the only xylene you had, no matter how long you left it in xylene 1 for, you'd probably have residual wax on your slide, which of course would prevent the xylene getting in. And then we're submerging in ethanol because we need to dehydrate for this aqueous stain. So we've got Celestine Blue and Harris's hematoxylin. So what components will they stain? Anyone know what they're going to stain? The Harris's hematoxylin? What's going to stain up with that? Yep, the chromatin. So the nuclei will stain nicely with Harris's hematoxylin. We'll give it a quick rinse. Then we put this Van Giesen solution on, which contains picric acid and Sirius red. So it's got 2 dyes in it, interestingly. So what is the principle of these trichrome stains? How do the dye? You've got multiple dyes. What is the key thing that sort of differs between the dyes? It's the basis of how the stain works, actually. Yeah, there are different colours. Well done. Yeah, so you can stain different things. But and they do stain different targets. But what is the basis by which they do end up staining different things? They're different colours, so you can see what they've stained. That's cool. Yes, well done. Their molecular weight. So let's move on a bit and have a look. This actually is a bit of adrenal cortex. Not much to see, except see how the fibrous capsule has really stained up nicely with this collagen. And there's not much collagen really in the zona fasciculata. We'll go a little bit deeper into, I think we might be down in the medulla now, the adrenal medulla. You can see that these endocrine cells of the adrenal medulla are subdivided into little packets by collagenous septum. So this Van Giesen stain has selectively stained collagen 1 color and sort of smooth muscle another. So it is one of the trichrome stains, and the basis is you've got different size dyes, larger dyes and smaller dyes. And the reason this works is the things we're looking at have different sized pores. So red blood cell proteins have small pores, and collagen has larger pores. So you find that when you put these dyes on the tissue, the smaller dyes go everywhere. Great. So we've got picric acid as the smallest dye, which is yellow. So everything would stain yellow. But then when we put in our Sirius red, which is quite a big dye, it can only get into the collagen, because that's the only place which has big tissue pores in it. So it gets into the collagen and pushes out that smaller picric acid. And so you're left with this sort of just the Sirius red in collagen. So that is the basis of the trichrome stain. We talked about it back. These slides actually come from the connective tissue extracellular matrix and special stains lecture. So here we go. You've got hematoxylin. We use Weigert's hematoxylin because it's acid resistant, because in the next stage you put on picric acid, which has a small dye. That pretty much stains everything. Then we put acid fuchsin on. In fact, in our lab slides, we substituted acid fuchsin with Sirius red. But as long as they're both big dyes, it works the same way. And that pushes out the small dye from the collagen, it can't push it out from muscle and red cells because it can't get into the red cells. So the red cells here have just got the picric acid in, they're staining really yellow, and the smooth muscle here of the coronary artery wall has stained with the yellow part as well, but the collagen is nicely selectively stained with this larger dye. So trichrome stains, that's how they work. That's cool. Oh gosh, 34 slides. Woof, hour and a quarter. That's everything I wanted to get through in this session. So we'll stop right there. I'll just go back to the first slide actually, because that had a couple of reminders on it, didn't it? Let's have a look. Make sure I haven't missed anything. Oh, that's right. There was the there's that pulse survey is on, isn't it? So you remember at the top there's a little survey, and also if anyone wanted to. Now a couple of you have emailed me. I'm embarrassed to say a couple of you have emailed me more than once. So please comment on this. I will do. Just haven't got round to it. It was quite a busy weekend. Mostly here doing photography and odds and ends. So I will. Those of you who sent me your assignments and sketches for comment on, I am going to be delighted to. It is not an imposition at all to look at those. So very happy to look at those for you. So do keep sending those in. Happy to comment on them, and I'm hoping that everyone is able to get on. So a couple of comments appearing up. So for H&E variation assignment, is tap water a bluing agent as well as Scott's tap water substitute? Yeah, so Scott's tap water substitute, we use that because the pH is at the correct value. Your tap water might be. So if the tap water is the right pH, it will act as a bluing and change the colour of that hematoxylin. But if it's not the right pH, it won't work. So that's why Scott's tap water substitute is used. So that little question that Felicity popped up there in regards to the H&E stain variation assignment. So anyone got any other queries or anything to talk about? So as I said at the beginning, I guess people logged on today. It's like a third of the class. I haven't heard from everybody, of course, not really expecting to. So I'm just sort of cheerily assuming that no news is good news. Don't know whether that's true. I hope you're managing to make progress with your H&E assignment and stain variation assignments and your drawings and so forth. I don't know whether anyone's had a go at the mid-semester quiz. I could probably find out by looking at it myself. But that is sitting there ready to do. If you haven't done enough of the unit to attempt that quiz, it's probably a timely reminder. We probably should have gone through most of those lecture recordings and so on, so that you feel happy attempting that quiz. So those quiz marks don't count for anything, for that mid-summative, but just a way of practicing, and I hope you find it useful. I will have a check in my archive because I might have a couple of online quizzes on the Socrative platform for a few topics. If I find those, I'll open them up to you and make an announcement. Okay. Everyone ticking on okay? So, down, so I'm going to stick a happy face up for me, so feeling a little bit happier. Slept like a wood chip last night, but otherwise, ticking along. Righto. Well, I think that's it for today. Got through in about an hour and 20 minutes, which I think is as much as we can handle sometimes, isn't it? No worries, Taylor and Lynn. Thanks for joining, and hope it's fun scribbling all over the screen and flashing out a few things and revising some of the lectures, or maybe visiting some of the lecture material for the first time. But do go back to those lectures and whip through the notes or the recordings if a lot of today hasn't made sense. Good. Okay, thanks everyone. See you next time, and I'll hopefully be in touch during the week with any online quizzes and odds and ends. Okay, thanks. See you next time.
See you. Bye.
See you. Bye-bye. Fabulous. Thanks to those of you who sent in those sheets as well. Thanks, Riley sent yours recently as well. Terrific. Getting up to date on that, bit by bit. Okay, I'll stop here. Thanks.